Page 1, exam review. In question 1, you're to identify precision and accuracy. Well, in the first sentence it says that there are two scales used to measure the mass of an object that was known to have a mass of 32 grams. So if you look at scale A and scale B and look at the number values for each of the trials, none of those are accurate values close to the 32 grams that we know the object weighs. So neither scale will be accurate. That answers question C. And then for question A, comparing scale A to scale B, the number values are closer together and are a cluster of numbers that are similar for scale B. Then the question B asks for the average, so add up the three numbers for scale B, divide by 3 to get your average value. Question 2 is asking you to identify solid, liquids, and gases based on their properties. So you need to go back and look at the slides on the PowerPoint review, exam review, if you're not sure about how to identify gases, solids, and liquids correctly using those descriptions. Question 3 is about the phase diagram that's in the exam review slides. So if you're going back from a gas, or if you're going from a liquid to a gas, that's evaporation. And if you're going from a liquid to a solid, then that's going to be freezing. Question 5 is asking about the subatomic particles. And you need to know that there are 3 subatomic particles: protons, electrons, and neutrons. And you need to know how to use the periodic table to identify any of those values. So the one value that identifies the existence of which element it might be is the number of protons. And that will always be equivalent to and the same value as the atomic number. Question 6, simply asking you for the ion charge or the oxidation charge of these columns on the periodic table. So if we go back and number all of the columns on the periodic table, 1 through 18, then the very first column, where it's alkali metals of hydrogen, lithium, sodium, so forth, they're going to have a +1 charge because they have 1 valence electron. But if you go over to column 13, which is the column with boron at the top, that's the third tall column, so it has 3 valence electrons. So it's going to give up those 3 valence electrons to be a +3. Then if you go over to column or group 15, that is the group where nitrogen is at the top. And if you count the tall columns going over and get to nitrogen, it is the 5th tall column. So it needs to gain 3 electrons to reach 8, so we'll have a -3 charge. Then the 17th column is actually the halogen group, where fluorine is at the top of the column. And if you count just the tall columns, that's column number 7. So that means it has 7 valence electrons, only needs to gain 1 more to reach 8, so the charge for group 17 is -1. Questions 7 and 8 go together, talking about the periodic trends and the size of the atom. The atomic radius, or the size of the atom, will decrease as you go across any particular one horizontal period. That's because you have the same number of orbital rings existing, but you're adding another proton to the center of the nucleus, while also adding another negatively charged electron on the outer ring, outer orbital, for each element. That increases the positive and negative attraction, causing the element to pull in on itself, that the protons in the nucleus are going to pull those electron orbital rings in tighter, closer to it, the more valence electrons that exist on the outer orbital as you move across. So the smallest size atom will be at the far right of any horizontal row. Then talking about ionization energy and electronegativity, that will be related to the size of the atom and be the greatest on the smaller size atom and the weakest on the larger size atoms.